start the recording now. Okay. Um, okay. Okay, so I've started the recording, and so today, um, you know, we're really happy to have Chris, like brilliant Google engineer. I mean, there's probably some parental pressure involved in Chris helping us, because his dad is a friend of mine and probably to date the best grant officer I've ever had. Really nice guy. And so, I'll have Chris introduce himself, but Chris, like his dad, is very humble. So I just wanted to tell you that Chris blasted through the UC Berkeley CS curriculum in 3 years. Even our own Joseph Lee, who's legendary, did it in four. Okay. And then when Chris was in high school, he was actually like a Seaman Westinghouse award winner. So that was like a big deal. Okay. And so these are like stuff that Chris will not tell you. And so, like in the Asian world, Chris is like the son that everybody wants to have, or like the son-in-law every like Chinese mom wants to have. Um, Okay, and so, anyways, moving on, Chris is going to tell us about GitHub and then Jupyter Notebook. And I just have to take this uh time and that propaganda rise from my Chinese soap opera. Okay, there are like these two soap operas that just air in this last 2 week. You can catch them on Netflix. Please support both of them. And our next session will be on July 11th, Friday. This is 7 to 9 a.m. Alexander the Great will be back talking about these two problems and then reviewing looping over list. And lastly, I know on Friday we didn't get an opportunity for Emma to introduce herself. So, Emma, can you please introduce yourself?
Hi everyone. I think I've met a bunch of you before, but I was one of the head teaching assistants for Code in Place 5. Um, I graduated last year with my bachelor's in computer science from Stanford. And yeah, now I'm doing this and figuring out what's next. But I'm really excited to be part of Life After Code in Place this year because it's a great community and I'm excited that we're continuing it. And yeah, Chris, thank you so much for being here to teach today. You guys have great instructors, and I'm excited for today's lecture.
Yeah, and so Emma is like the best present that Cameron bestowed on Life After Code in Place. Okay, and then one last thing, as those of you remember from our first session, okay, in an effort to try to motivate people to come and actually learn via Zoom rather than learn in a vacuum by watching the videos, we're going to have these intermittent like small quizzes with sort of like awards. Okay. They're not anything big, but if you want to get like a cup of coffee or if you're somewhere in the world, like China, where things are very cheap, you could probably get more than just a cup of coffee. Okay. And so this is our week's quiz on the next slide. So this is time to test your internet speed as well as finger speed. So the first person to type in the chat, okay, the name of this location and the country. You have to have both, okay? The name of the location and the country will win, okay? So I'm going to go to the next slide. This is our location for this week. So if you think you know where it is, oh, wow. Stanford. Okay. That was really fast. Okay, so Paul. Yes, Paul has it correct. Okay. Nick, quick as you are, you just weren't fast enough. And so Paul, I will um, you know, text you privately if you want to send me your email. And then I'll send you the gift certificate. So this is indeed Lake Tahoe. It's on top of Heavenly, which is one of like my favorite ski resort. Okay. So I'm going to stop talking and hand this over to Chris. Okay. So, Chris, if there's anything you want to add about yourself that that I got wrong, feel free.
Yeah, no, thanks for the amazing introduction, Vicky. I definitely feel like you made me sound better than I feel like I am, but no, really appreciate the hype. But yeah, a little more about myself. I graduated college from Berkeley in 2020, and I've been working in tech since then. So out of college, I worked at Amazon for about 2 years, and I've been at Google since then. Um, but yeah, this is a great program, and I'm really excited to be helping out with the instruction here. There's a lot of interesting topics, and I feel like it's great that you all are interested in learning. So yeah, happy to teach. Um, but yeah, let me get started sharing my presentation. Let me see if I can find it. I believe it's here. Um, so are you guys able to see this? Sweet. Great. Love the feedback. So yeah, I think Vicky covered this briefly, but the agenda for today is going to be um, version control in GitHub, as well as Jupyter Notebook. So we're going to try to cover all of that in these 2 hours. So there's going to be a bit of hands-on activity with this. So I wanted to start off just like get it out of the way to install a couple of the programs that we'll be using. So the first one would be Git. Uh, there's a couple of installation instructions for whatever operating system you're on. Um, and then we're also going to install a Jupyter Notebook, but that's just like kind of a sneak peek. So um, let's start with installing Git. Um, I guess like I didn't really have much planned for this apart from hoping that you guys would read the slide and trying it out yourself. But I'll just set aside like maybe the next 5-10 minutes or probably longer for you all to try installing. And then if you have any questions, feel free to drop it in the chat. I think any of us, Emma, me, or anyone else can try to answer your questions if you're having issues with it or questions at all, just in general. Um, but yeah, one thing to note for the Windows installation, I recommend using something that's installed along with Git called Git Bash. It's sort of like a terminal similar to what Mac OS and Linux have. So I would suggest at the very end of the installation process, um, just check the box that says Launch Git Bash. It should open the Git Bash window, and you can just leave it open until we get to the interactive portion.
Chris, and so if we're on a Mac, we need to get to terminal, right?
Yeah.
What's
Um,
the shortcut? I know there's a shortcut on the Mac to get to terminal.
I'm not the best at these shortcuts. What you can do, I think there's like a search button somewhere.
I was just typing this in the chat, but I'll also say it out loud. If you are on Mac, you can press the command, which is like the key right next to the left of the space, command
Yeah.
and space at the same time, and that'll bring you to search. And then if you type terminal and click whatever comes up, then you'll get this little like black window that looks kind of like you're hacking in a movie, like the way they show it in the movies.
Wait,
Um,
command spacebar or
yeah,
what?
so command and spacebar at the same time should bring up the search.
Command was, oh, there it is. And then you type terminal.
Yeah, and then you type terminal. And then you'll get this like little window.
Yeah, yeah, okay.
Okay. And then from there you can run git dash dash version.
So that command git version, is it installing git or git should already be part of your terminal?
so I believe, so for me, it's like hard to say since I've had it installed and I don't remember installing it. But from what I read online, it seems like if you just type git dash dash version in your Mac terminal, it should prompt you to install it. And if you already have it installed, it should just spit out the version of Git that you have. Let me know if that's not happening for anyone. Did not prompt to install. Um, let me see.
Someone asked, oh, Git is
Yeah, let me see if I
I'm
can.
So if you're on Mac, there was a question in the chat that I wanted to address. The question was, should I download it first or just call it from the terminal? And if you call Git version, just like is on the screen, it'll it should tell you that you have a version of Git, probably. It'll be like version and then a list of numbers, like maybe like 2.5 or something like that. And it's okay whatever version you have. But if you don't have it and it gives you some error message that says like Git not installed, then you can run brew install Git, which I'll put in the chat. And then you can try Git version again after that and see if it gives you the number.
Great, thanks so much, Emma. I see there are a couple more questions. Let me try to answer them just verbally. So I see someone asked, what should the default editor for Git be? I imagine if you're installing on Windows, it will prompt you for that. I'm not sure if it prompts you for Mac, but you can just leave whatever the default is. I believe the default says like Vim or something. Um, you should be able to change it later. So I think it's safe to just click through all of the default options. Um,
any version is okay, right, Chris?
yeah, most versions should be okay. Oh no, terminal's correct. We should be using terminal. Yeah, for Windows installers, there's a lot of options to click through. It does feel a bit intimidating, but um, it should be fine if you just keep clicking next. Um, Usually the default configuration is good enough for us. A couple questions. What is the role of the git bash shell? Yeah, I see git commands can also work from the Windows command terminal. Yeah, you're right. It can work from both. The git bash shell seems to emulate like the Mac OS and Linux terminal the most similarly. So this way we can all kind of follow along in the same way. Because I believe the Windows command terminal has slightly different commands than Mac and Linux. Things look good. Vicky or Emma, sorry, I'm not too familiar with Zoom. Do you know if we can use the poll feature here to
Yes.
check on
Yeah,
So,
people's?
why don't
if you look at the bottom, there's a more. Okay.
Yeah.
If you go to more, under I think option 4, there's a poll quizzes.
Hmm.
And so you could launch that and then make your own poll question. Or I could just make one for you.
Oh, I think I launched an old one.
Yeah.
I'm
So
not sure how to.
yeah, what do you want to make? I could make
Um,
a
can we
question.
just have like a one question poll, and people will vote when they're ready to move on to the
Okay,
next.
ready or not? Um, and so say yes and then no, right? That's all you wanted?
Yeah, honestly, just yes is good, and folks can abstain if they're not ready yet.
Okay. Okay, so save to a library. Okay. So people can see the poll.
Thank you, thank you. Looks like we have about 70 participants.
Yeah.
Okay, I think we're looking good. If anyone continues to have issues, feel free to just drop any questions or messages in the chat. I'm going to move on to the next installation, which is Jupyter Notebook. Um, so for Jupyter, we can install it using this link. Let's see, let me drop the link in the chat. Um, so yeah, this should bring us to a download web page. Choose the downloader for your respective OS. And then once Anaconda completes downloading, you should have Jupyter Notebook installed automatically. And the way to launch Jupyter Notebook is going to be different between Windows, Mac OS, and Linux. Um, so
Chris,
yeah,
how do you check if you already have Jupyter Notebook? Do you just type Jupyter Notebook and see if anything comes up?
yeah. So for Mac and Linux, if you just open your terminal, try typing Jupyter Notebook, you should be able to see whether or not you have it. Um, If not, then you can follow the installation process. But if you do, then it should launch Jupyter Notebook in a new tab on your browser.
So
Um,
when I type that, oh, okay, it just automatically launches. So awesome.
oh, perfect. So you must have it installed already. Um, yeah, I see someone dropped. You can do pip install Jupyter Notebook. That works as well. But I think you need to have Python. I'm not sure if people have that or not, but I think Anaconda is probably the most surefire way. But if you find other ways to get it installed, that works as well, as long as you're able to run the Jupyter Notebook command and launch the notebook successfully.
Chris,
Um,
can you just talk briefly about what is Anaconda, what is Miniconda, what is Mamba? I mean, I hear these terms thrown around a lot, and I'm not sure exactly what they are, really.
yeah, I believe Anaconda. I don't I don't work too much with it, but I believe it's just kind of like a software that helps you install like relevant programs for um, I'm not sure if it's just for data science or for just like different kinds of projects, but um, yeah, I just know it comes with Jupyter Notebook.
Do you guys know Emma or one of the other SLs online? Like, um, I had heard that all of these things, forget the term, but they could help you check for dependencies so that if you, I don't know, like download different modules, they'll make sure like they um they basically have the right I don't know, like version to kind of launch that module. Does that make any sense?
Hello, Chris. Can you hear me?
Hi, yes.
Yeah, hi. So just responding to what Vicky said, actually, when one starts to get complicated, it is really important to have all the right dependencies in a particular environment. I started using Anaconda and then I gave up on it because it automatically installs a version of Python without having much control over it. It's going to give you the most recent version. I didn't like that. A whole separate topic is how to use venv, venv, in order to set up virtual environments. It's not necessary for today, but be cautious about Anaconda. It seems simple and helpful, but it can get you into trouble.
Yeah, that's a good call. It it's helpful in the sense that it kind of does a lot of these dependency installations for you and manages that. But once you hit the point where you need a specific version of something or um, something else, then it might cause certain issues. It definitely takes a bit of getting used to.
Chris, there seems to be a lot of questions in the chat about, whether to download distribution. I don't know what that is
Yeah,
for,
sorry, I missed the message.
or
But
or Miniconda.
yeah, let's do distribution installer. Sorry for not answering that earlier.
What is that?
Um, I'm honestly not sure. Sorry. Um, I'm yeah, I can't answer that. So just to set up like Jupyter Notebook, I found like the most straightforward way for folks to install Jupyter Notebook across multiple platforms is just through Anaconda. Um, I'm not trying to vouch for Anaconda or like, propaganda for suggesting Anaconda is the way to go in all cases. But in this case, it gives us Jupyter Notebook, and I think um, that should be sufficient for our use case and whatever projects we'll work on throughout this class.
Yeah, distribution is just going to be the full thing, which is very large, and then Miniconda is a stripped down version, which just has the bare minimum, and you can install extra packages if you need it.
Sweet. Thanks for that answer. Cool. Other questions? And again, for Windows installers, I think we can just use the default options. So you just leave whatever checked and just hit install. Cool. And Vicky, could we create another poll
Oh yeah.
for this
So
download?
I could just I think relaunch this poll.
Yeah, that works too.
Relaunch the same poll.
So yeah, once y'all are able to launch Jupyter Notebook successfully, please hit yes in the poll. Expected output for Jupyter Notebook, the Jupyter Notebook command is there should be a window that opens in your browser.
So it looks like there's a number of people where Anaconda is taking time to install.
Right. Um, yeah, it may take a little bit longer, although hopefully if we're at that point, we just have to wait for the install to finish, and then we can launch the navigator and just launch notebooks. Let's give it one more minute till the 30, and then I'll get started, and hopefully people will slowly just let the installation continue as we cover other topics.
Yeah,
Um,
because you could run Get without Anaconda, right?
yeah, completely separate
Right.
topics. Someone also asked, I think it's a good question. So yeah, sorry, I should have vocally covered it, but someone asked if I'll be covering how to use Git for Jupyter Notebook. Um, it's a bit awkward to use them in combination, so I'll be covering them separately. Um, Jupyter Notebooks doesn't do version control super well, which is what Git is. Um, so we'll just be talking about them separately in this case. Um, and then for folks in Windows, I see some people are finishing up their installation. Um, if you can just on Windows, if you search in the Start menu for Anaconda Navigator, um, see if that pops up. Once the installation finishes, it should appear in your applications. But yeah, it looks like slowly people are slowly finishing up. So feel free to continue dropping questions. Hopefully, some people can answer them in the chat, but I'll get started on some of the content that we'll be covering today. So yeah, let's get started with version control in GitHub. So I wanted to start off by giving an overview of what version control is and how it can be useful. So basically what a version control system is it's something that allows you to record changes made to code over time. So you guys have probably done some form of version control manually in other, like outside of like data science and coding. Um, for example, in this image we have the bottom left. I'm sure people have written essays or theses, and you always know that like the first final draft you have is not really the actual final draft, and then you eventually create another version of it and another until you have what your actual final is called final draft v20. So version control kind of is a system that automates this process a little better, so that you don't have to create a whole new version of your code every time you make a change to it, and you can still retain that form of keeping previous copies of old versions, because that can be useful in other ways. So here's like a list of reasons why we like to use version control. Um, it allows us to revert selected files back to previous state. We can also compare changes that were made over time between different versions. We can also see, so this is kind of jumping a little bit forward, but we can see who last modified something that might be causing a problem in the code. So version control systems allow coders to work collaboratively. So if there's one person that made a specific change, you can see who made that change and maybe ask them for more details about their change to get to the root cause of what the problem in the code is. You can also, I guess this is similar, but you can see who introduced an issue, and you can also see when it happened, because the version control system also stores metadata and other information about time and like who made those changes. And you can recover lost files. You can probably think of a lot of other reasons why keeping versions is useful. Obviously, this idea is not limited to coding, but version control system is just how coders typically manage keeping track of different versions of their code. So moving on to what we just downloaded, Git. It's a popular distributed version control system. And what we mean by distributed is essentially just it allows multiple developers to collaborate on a single repository together. So multiple developers in this image can all contribute to the same shared repository. So yeah. By the way, these slides should be shared out after the session, and I've attached some links for where I got a lot of this information from. And if you want to read more about specifically what the slide is covering, there should be like at least a link at the bottom right that gives you a little bit more information if you're just curious. But at a high level, that's what a version control system is. If you're interested, you can read more about it in the Git documentation, which is linked there. But
Hey,
yeah,
Chris, can I ask you a couple questions about the version control?
sure, go
So,
for it.
So I guess like one of the questions would be like privacy. Okay, if you're working on some like super secret Google project, I'm sure you have like your internal version control, right?
Yeah.
And so how do you safeguard, everybody from everyone else like pulling stuff from your own private version control system? And then secondly, where does Git actually store the information? Is it on your local computer? Is it on cloud? And so if somebody else, has control to your like GitHub repository, and then if it's saved on your local computer, does that increase the chance of them like hacking into your computer? Do you know?
Yeah, so that's a good question. So conceptually, Git is not the same as GitHub. Git is kind of like this version control system that GitHub kind of builds off of. So you can actually use Git like completely locally without having to upload it to like an online repository like GitHub. So if you're just working on your own project, you can kind of store that completely locally on your own computer. And people would only be able to access that if they have access to your computer. What we'll see later on is that we can upload our code to GitHub. And this is where like, I guess that idea of your code privacy is like more important. Um, I'm not fully versed in how to use like specific options within GitHub, but you can make private repositories and you can prevent other people from uh, like seeing your code, I guess. Um, for I guess like uh, for Google, yes, there's like an internal version of Git and GitHub, so that is all kind of like isolated to its own um, kind of bubble. So anyone externally does not have permission to access it.
So
Uh,
Chris, just a one thing to keep in mind is that on GitHub, when you set up GitHub, you can create a private email. It's actually pretty easy to do. And so that is another, I think, useful privacy thing that one can opt to do. Just FYI.
yeah. So yeah, like that's helpful. Thanks, Nate. So like I said, I don't use GitHub as much as I used to, so I'm not super familiar with like the privacy settings there. But there should be ways you can kind of play around with that and figure out how you can uh, make your code private and not accessible by other people. Yeah, that's
Um,
certainly a good concern to think about, though. But yeah, go on, Vicky.
Yeah, this is a question for the section leaders, because Chris is not familiar with the code in place IDE. But I'm just curious for the section leaders that are familiar with the IDE. If you go to the IDE, there's a place where you could like look at umpty versions of your prior code. And so if you like somehow lost your code, you could actually go back and then restore like a private previous version. And so just curious if that is a form of version control system, and then whether that the IDE is engineered based on a similar idea of the version control system. If
Yeah.
anyone knows, I mean,
Oh,
I'm just curious.
yeah, maybe.
Yes, that is a form of version control. It's quite a bit simpler than Git and, other professional level version control. For example, it just auto saves whenever it feels like instead of you manually saving whenever you have a particular milestone. And you can't do things like add a message when you save a milestone, or commit is what we call it. But yeah, so it is a form of version control, just a simple one.
Cool. Thanks.
Yeah. Thanks for that answer. Yeah. So to kind of build off of that, there are many different forms of version control. It doesn't have to be the same as Git, but Git just happens to be like kind of the most popular one that's widely used. Um, so yeah, great question. So moving on to this next slide, Git, or like I guess concepts about Git specifically as a version control system. So Git has three main states that your files can reside in. We have something called a modified state, which means the file is modified or changed, but it hasn't been um, added as a new version yet. So basically, the file has been changed to be different from the most recent committed version. And we'll talk about what that means when we get to the committed state. But the next state is staged. So this essentially means that you're marking one of your modified files as ready to be committed into the next version. And then finally, we have a committed state, which essentially means we've marked the stage changes, collected them into one, what we call a commit, and that's marked as like the next newest version. So an idea of a commit is like essentially a version of our code. So every time we make a commit, we're making a new version of our code. And then these three states, all of your files within your file directory um, be will kind of cycle through one of these three states, as long as they're within Git.
Chris,
Um,
why do you need so many different states? I mean, why can't you just, I mean, because like if you're writing a paper, okay, you basically
right.
have like a final version and a draft version, I mean,
Yeah.
it seems like you have so many intermediate stage. Oh, why do you need so many intermediate stage?
Yeah, that's a good question. So when you're writing a paper, the idea is you have like, I guess you're writing. I think it's pretty similar, but we're kind of like uh, codifying it a bit in the sense that we're like attaching rules so that we can um, follow like a specific structure so that we can generate these sort of drafts and final versions. So think of it as like when you're writing your paper, um, if you start from like a blank slate, or like say you have a previous draft and your current draft that you're just starting. So for your current draft, you would probably copy over what your previous draft looked like, right? So then you would copy over everything from your previous draft and then start a second draft. And if you make any changes to that, that's considered like a modified draft. And then once you decide that the draft is ready to be sent for review by like your professor or something, that's considered like a committed draft. And then kind of the in between is staged. Like staged and committed are kind of close together in the sense that like staged means we're marking this file as ready to be committed. And then once it's committed, think of it as like you're sending it to your professor for review or something.
Right. I
Uh,
mean, that intermediate, like staged, okay, just seems to me like it's not very relevant. Like, why do you
yeah.
need
Yeah, no, that's a great question. It does seem like we really only need modified and committed. In for like let's say in relation to coding specifically, when we're working on a project, it's not limited to just one file, like one single document. So we're gonna have like a lot of different files. So like when we create a version, it doesn't mean we're creating like one single draft of like one single paper. It's that we have like a lot of different files that we might have added or changed or renamed or moved. Um, and we want to like mark the specific files that we want to include in the next version before we commit it. So like say we have like file A, B, and C, but we only want to commit files A and C, then we'll only stage files A and C, and then make that commit. And so files A and C will be in this current version while we're continuing to work on file B.
And so is it safe to say it's like a filter process?
Yeah, I think that's a good way to think about it. So
Just
yeah, like we'll also be manually moving the files through these different stages. So it's like, it's not like these files will kind of automatically go between like modified, staged, and committed. We're kind of marking specific files as staged. And then we're choosing what gets to be committed by selecting what gets staged. But yeah, does that answer your question?
Thank you.
Cool. So yeah, moving on to a little more details about Git. There's also three main sections of a Git project. So we have the working tree, which in this diagram is called the working directory, the staging area, and the Git directory. So the working tree is just the current working version of the project that exists on your local disk. So this is just like whatever is like in your code directory on your personal computer. The staging area it just tells us what information is going to go into our next commit. So this is obviously related to the staged state of a Git file. And then the Git directory is where Git stores all of the version history for our project. So kind of the flow of this, I guess watching over this diagram, we'll see in the next slide that we have like a basic Git workflow that kind of follows these arrows. So let's see, the basic Git workflow, we'll modify the files in our working tree. So modifying them moves those files into the modified state. And then we'll selectively stage the changes that we want to be part of our next commit or version. And that will add those changes to the staging area. And then you do a commit, which will take the files from the staging area and store the snapshot or that version into the Git directory. So looking at this diagram, we'll start with from the Git directory or repository, we're checking out the project, which essentially means we're pulling a version, which is usually the latest version, into our working directory. So this will just like make our working directory whatever version of that we want from the Git directory into our working directory. And then you can see from working directory to staging area, the arrow says stage fixes. So this essentially just means we're converting the modified files from our working directory into staged files, which would exist in the staging area. And then lastly, we have the staging area into the Git directory, which has this arrow set that says commit. So this is essentially converting the staged files, which we selected to put into the staging area. And we want to convert them into committed files and ultimately create like a new commit or a new version of our code. Yeah. So going a little bit more in depth about like the life cycle of a file within Git. So we have a couple more like essentially states, but think of it as more of like the status of like a file and whether or not it's included in Git. But we have like a project that contains files, and these files are either tracked or untracked by Git. And what that means is untracked files are essentially just files that Git doesn't know about yet. And then tracked files are files that Git does know about, which means they would be categorized as modified, staged, or committed. So we have this new diagram that basically describes like how a file can move through these different statuses. So when we have an untracked file, this is something that Git doesn't know about. So usually when we're like creating a file from scratch, so adding the file to Git means that we're immediately moving it into the staged status. And then we have additionally like an unmodified file. So this means that the file is tracked by Git, but it hasn't been changed. So this, like, the only state that this can go to is to modified once we've edited the file. So that will obviously change the file and then convert that file from committed or unmodified into modified. And then moving from modified to staged, this is just us marking this modified file as staged. And then from staged to unmodified means we're committing the staged file, and now it's no longer considered modified relative to the last version, because the last version is what we've just committed. And then finally, from unmodified to untracked is just removing a file. So it's no longer part of the directory, and therefore it's no longer tracked by Git. And also usually it just doesn't exist in the directory anymore. But yeah, that's usually how the files can move in between all of these states.
Do we actually have to know this to work with Git? Because there's like no way I can remember.
Not at all. So
Wait.
I think like it will conceptually start to make sense as we play around with it. But this is more of like a attempt to like visualize how these can move between the states. There's definitely a lot of like hands-on playing with Git and like trial and error that you'll go through to understand exactly how the version control goes on. But this is more of like an introduction to what exactly goes on within Git. And like it should hopefully help you understand, like, if you run into certain problems with the version control system, why like you're running into those problems. So I know this is like a lot to take in at first, and don't feel too overwhelmed by all of this information. But try to remember that there are these different states that we can that a file can be in, and you'll slowly start to piece together how they can like move between each state. So I'm hoping that this will like be a good introduction towards the Git states, and then once we do our hands-on project, then it should make a little more sense. But yeah, don't feel too bad if it's not making complete sense now. Just try to remember what states exist, and then we'll see how we can move between the states once we do our hands-on project. So for Git commands, I'll run through these really quick. Obviously, this is going to be impossible to remember all in one go. So I'll just run through them really quick. A lot of them just talk about how we'll convert between different states, and then we'll see how they work when we do our demo. So yeah, we'll start with git init and git clone. So this is how we create a Git repository. So init will initialize an existing directory as a repository, and clone will retrieve a repository from a hosted location, which is often GitHub or some other URL. We have git status, which tells us the status of all the files within Git. So they'll tell us like what state each file is in. And then we have git add. So add tells us, or add will add a file to the next version, or sorry, to the staging area, which is essentially means that we're marking either an untracked file or a tracked and modified file into a tracked stage file. So it's essentially this arrow that points from untracked to staged, or this arrow that points from modified to staged. So that command covers these two arrows. We have git restore -- staged. So this will unstage a file while keeping the changes in the working directory, which essentially just means we're moving a tracked staged file, which is from this red zone, to a tracked modified file. So there's no arrow here, but it's like if we stage the file, but we realize we don't want to stage it for the next version, then we can undo that change by putting it back into the modified state. Git diff will tell us the difference between our current staged, our current modified versus our latest version. Git commit will commit our stage content, So it will mark the track stage file as a track committed file. So essentially this arrow from staged to unmodified. And then git log will show a history of all the different versions or commits that exist in our Git directory. So this is kind of just a peek at how we're going to be using Git in the terminal or the Git bash. And this is a lot to take in again. So if you're ever confused about how to use a specific command, you can just say git verb dash dash help. So if you're confused about git add, you can say git add dash dash help, and it'll pull up a page in your terminal about how to use that command. So yeah, I know that was a lot, but hopefully this will kind of tie everything together. So I'm hoping to do like a demo that you guys can follow along with now that you have Git installed. And we'll go through all of these different points and we'll just try out playing along with Git. So let me share my a different screen. Let's see. Yeah, sorry. Also, I'm now just seeing a lot of the chats. This is a lot. I'm sorry for kind of overwhelming everyone with all of this information. But again, hoping this demo will at least start to tie some of the things together. Don't feel obligated to like memorize everything in the first go. You'll definitely pick it up as you go, and use Git. But yeah, let's do this. Demo. Are you all able to see my screen? Am I sharing?
Yes.
So this should be like a terminal. Yeah, I think I'm sharing. Okay. Sorry, I'm pretty new to Zoom. Cool. So the first thing we want to do, so this is assuming that we haven't used Git ever before, is we want to set up our username and our user.email so that Git knows whenever we make a commit that it's us making the commit. So we're going to start with git config -- global user.name Chris. So this is the first command, and there shouldn't be any output. So you guys can try adding that with your name, or whatever you want your name to be in the Git.
What does that command actually do, Chris?
Essentially, it just it updates your configuration so that whenever you make a commit or essentially upload like a version of your code, it ties that version to your name. So like when we're working collaboratively, for example, and there's a lot of different people contributing to the code, you'll be able to see who was like responsible for which version. And this is just setting that up so that anytime we make that commit, it knows who to tie that version to.
So I guess if you don't want people to know that you screw up the code, use like a false name or something, right?
Yeah, definitely use a
And
false name if you think you're gonna screw up the code.
um
But
and and then if you log out of terminal, do you have to actually repeat that command every time you log back into
great
terminal?
question. So it should set it once and for all. So once you set this once, you don't need to set it again.
But if you want to change your name, you would run it again.
Yeah, you can just update it. It will overwrite the existing username. So then you can also set your email. And yeah, feel free to input whatever value you want here. This is more of just like something that people should go through, just like for if you, in the future, if you're working on a repository with other people. But for the most part, what we're doing here is going to be isolated to your own repository. So it doesn't really matter whether or not you use your real name or not. So yeah, type whatever you want. For example, like I can say like chris@chris.com, something. Yeah, so that's the these are the commands. Yeah, and someone asked how to check if it actually worked. There's no output to the command, so obviously you don't know if it actually worked, but it's essentially just setting something in like a configuration file. So as as long as like something crazy doesn't spit out when you hit enter, you should be good to go. Great. So moving on, we have our first our first changes. We want to make a directory. So this is going to be hopefully not too confusing, but we're going to create a directory using a command called make directory. So let's call this hello world. Oh, I already created it. Let's call it code in place. Call it whatever you want. And then let's change directories to code in place. So essentially what this first command does is it creates a new folder, and then cd is change directories. We'll move our terminal into that folder. So now our workspace exists like with reference to that folder. So once we do this, we can type get init, and that will turn our code in place directory to a Git directory. So now this means we have this version control activated, and we can start making commits to our directory. So we're going to start off by just typing git status. This is one of the commands that we talked about. You can see that it says no commits yet, nothing to commit. This all makes sense because our directory is completely empty. We just created it and we didn't add anything to it. So let's start with creating a file.
Hey, Chris.
Yeah.
And so when you have a file that's initiated as a Git repository, how's that different than just a regular file that exists, on your desktop?
Yeah. So a regular file will not be version tracked essentially. So if we type git init, that will turn this directory into like a Git directory, which essentially means that we're now able to start tracking like different versions of that folder or that directory. So you could technically turn like your desktop folder into a Git directory if you wanted to. But not everything works super well with Git. It's mostly for like code and text, where like the difference between the files are pretty easy to see.
So let's hypothetically speaking, if I turn my desktop folder into a Git directory, does that mean like no matter what kind of stuff I have on my desktop, whether it's like an image, whether it's like a text file, every time I make changes to it, it's going to kind of save a different version?
So that's also another great question. So Git is something that does version control more in like a manual way. So all of the versions are completely dictated by the user, which we'll see in this demo. It's not like something like Google Docs where every time you make a change, it will, or periodically when you make a change, it will auto save and mark it as like a specific version and just keep track of that like arbitrarily. We're actually defining what each version contains. So you could be the one to decide like, oh, I'm going to change this image and I'm going to mark this as a new version. And then when I go back, I can also see what the old version of the image looks like. You can do that, but it's not going to automatically save. Like if you're making multiple changes, if you're like, I don't know, if you have like an essay on your desktop and you keep updating it, it's not going to automatically create a new version every time you open the file and change it.
Um,
It's all
uh,
done like by the user.
and then one other question, does Git do version control on sort of all types of files, regardless of the content. And so let's say if you have like an audio file or a video file, is Git capable of doing version control on that? Or does it have to be, I don't know, like a string file? I mean, I don't think I've seen any other type of files
Yeah.
besides string.
Great question. So technically, like you could put that kind of stuff in a Git directory, but it wouldn't be able to handle it very well or efficiently, or like it might not be able to even tell like what a change to that file specifically means.
Why not?
So Git will like a change to a file is something that Git notices by just like I guess okay, taking a step back, like all files can be represented like as I don't know, like say you're like, have you ever opened like a file on like TextEdit, for example, and like if
Yeah.
you open an image on TextEdit, it's not gonna be represented as
Right. I
like
mean, it looks like a mess. I don't even
yeah,
know
exactly. It
what
looks
it.
like a mess. So like GitHub will essentially see this for all the files, and if you change a file, um, Git will technically know that the file has been changed, but it's not going to be able to tell you like what specifically has changed. It will just see like, oh, this is what the file in TextEdit looks like before, and this is what the file in TextEdit looks like after, and this is like the difference between the two. But that's not really useful for us because we can't look at that difference and understand what that means like between the two versions, if that makes sense. So it's most useful for like files that can be represented in like a way that we can read it. Um,
Okay.
so this usually means like text files or code is like the most commonly um, used in version control for Git at least.
Chris, just to
Um,
add on to that, and I know you're not going to cover it today because you already answered my question on it, but um, given that we're going to be talking about Jupyter notebooks today, one of the things I was hoping to be able to use Git for was to keep track of all my multiple Jupyter notebook files, but I found out it's really, really complicated. And I guess you agree. So that would be one example where you can get into a lot of trouble, a lot of complexity if you try to do it with Jupyter notebooks. Agreed?
yeah, exactly, and that's a great point to reference. It's the same idea where Jupyter notebooks aren't represented exactly the way we would expect for Git to like recognize. So when we make changes to the Jupyter notebook, it's not going to be able to be identified the same way in Git as if we were to make changes to like a Python file, for example. So yeah, great reference. But yeah, moving forward with the demo, we're going to create some new files. So I'm just going to write hello into file one. This essentially just like creates a file called file1.txt with the content of hello. It's just a text file. And then we can also see, let's do hello into file2.txt.
You're
So this,
basically writing into these get files using command line commands, right?
sorry?
Okay, you're basically writing into the get files using standard command line
Yeah,
command.
exactly. So uh, I can do like, so cat essentially will display like the contents of a file. So if I do cat file one, it should say hello. So this is like whatever is contained in that file. So if I do it for file two, it will also show hello. So if we do git status again, after we've created those two files, we can see that we've added these two untracked files to our directory. So what we can do to both track them and mark them as staged is say git add, and we can just add a star for all the files in our current directory. So now when we type git status, it shows that these two files have been, here it says changes to be committed, which is essentially saying that these two files have been staged, if that makes sense. So staged, again, is that state of the file. So now let's do, let's update file one. So let's do, if you guys are familiar, hopefully this doesn't confuse folks too much, but let's open file one in Vim. So this is like the contents of the file. And then let's add hello world. So let's update the file to
How do you
hello.
open it in BIM?
So I just typed VI.
Oh, okay.
Yeah. Vim is a little bit hard to use. So for folks following along, sorry, I'm forgetting. Let's just do, you can also say echo world and then double greater than file1.text. So this appends world to the end of file1. So when we open file1 again, it shows like we've added world to the bottom. And again, if you want to see what the contents of your file are, you can just say cat file1.text. So this is what our new file looks like, or what the updated contents of our file looks like.
How do you get out of Vim?
So you're going to hit colon, and then if you made a change, you're going to type WQ, so that writes the change and closes the file. If you didn't make a change and you just want to get out of Git, you can just type :Q, and it should exit. Great. So the next thing we're going to do is we're going to check Git status again. Now that we've updated the file, you can see that our original changes of adding file1 and file2 are still staged, but now we've made a change to file1. So file1 is so the addition of file1 is staged, but the modification of file1 is not staged yet. So it's considered like a modified state. So we can check what the difference is by doing a git diff. So here we see that like the change has not been staged, but there has been a change made to the file. So file1.text is modified. If we do git diff, we'll see that like here's what we've changed in the file. So this minus means this line has been removed, and then the plus means this line has been updated. So we've essentially changed the line from hello to hello world. So that's what this is. And then we've also added world to the end of the text file. So that's what this diff means. So now we can add the modified file1 to our staging area. So we'll do that by saying git add file1.text. Folks are saying they can't get out of Vim. Sorry for trapping you guys in there. I forgot. Try :WQ or :Q exclamation point. One of those commands. Hopefully that works. If it looks like you're typing, here, let me actually just save some people. If it looks like you're already typing like here, just hit escape, or yeah, and then type :Q again, and it should get you out. But yeah, so going back to where we were, we just added file1 to our staging area again. So now when we hit git status, we can see that file1 has been staged. We can also type git diff again, but git diff will show us only the difference between the modified state files to the latest version. So git diff doesn't output anything. But if we want to see the difference between the staged files and the most recent version, then we can type git diff -- staged. And this should show us that we've added these two files from basically nothing existed in this directory before. So now let's commit that change. So let's say git commit -m creates file1 and file2. So what this means is we're creating a new commit or version of our code. And this message is essentially a descriptor of what this commit does. So that when we look back on our previous versions, we can tie it to like some sort of description that lets us remember like what exactly we did in that version. So once we hit git commit, we've created a new commit, and that's updated file1 and file2 into our committed status. So now when we type git status, it says nothing to commit. Our working tree is clean. This means that our working tree is identical to the latest version, which makes sense because we just hit git commit and uploaded like a new version to our Git directory.
Chris, I have a quick syntax question for you.
Sure, go ahead.
Use the git add command. I get how you use it to get all of the files in a folder with the star symbol. And I also get how you just add one file name. But let's say you had 10 files that you use as examples. let's say I wanted to choose 1, 3, and 5. What would the
Mhm.
syntax for the add command be? Just commas after the files, or how does it work?
Yeah, it would probably be best to just say like get add file 1. And I think you just space them apart. So you can do get add file 2 dot text, or like say file 3, and then something like that.
So you just add them with the space in between. That's all you do?
Yeah.
Okay.
And then here it says I don't have file 3. So that's why that failed. But yeah, you just add them with the space.
Okay. Thanks.
Yep. Cool. So moving on, let's look at the git diff again. So we have git diff. So because we don't have any modified files and we just made a commit, this should also return nothing. But now let's make a change to file 2. So let's say echo world into file 2.txt. So again, if we want to see the contents of file 2, we can type cat, and we can see it's hello and then world in the bottom. So now we're going to want to add file 2 to staged, or staged state. And then if we type git status, this should show file 2 as a staged change. So let's commit that as well. Say updates file 2. And then now we've made 2 commits at this point. So we have 2 separate versions of our code. And then we can do a git log, which will show the history of all of our commits. So you can see that there are these 2 commits. Our first one, we created file 1 and file 2. And then our second one, we updated file 2. So if you want to see the difference between 2 commits, you can type git diff and then pass in additional arguments to it. So you can say git diff between this first commit. So we'll copy the commit ID, which is this, and the second commit. So we can copy this commit ID. And it should show us the difference between the 2 commits. And you can see the difference says that we just added world to file 2, which is essentially what we did earlier. If it's too much to copy, you can also take like the first couple characters. So you can say like, here, this is for 4E74, and then the first commit is 3C09. And then it should tell us the same thing. So we don't have to copy the whole thing. Yeah, let's see. Yeah, short log is also useful. Vim is a nightmare. Takes a bit to learn, but it's great. Let's see. Why do I have master after my directory code in place? This is so that's basically the branch name, which we're not going to cover today. But in git bash, it will show the branch name, I believe. When we say git status here, you can see like we're on branch main. You'll usually see it as main. I think on older versions of git, it's still called master. But that's what that is. It usually defaults to one of those 2. Yeah, moving forward, let's say the change that we added in commit 2, so when we updated file 2, was actually not something that we wanted to do. And instead, we wanted to say hello worlds, plural. We can update that by saying, let's say, to avoid using Vim again, let's just echo S, or let's say like hello world world. So we want to update it with 2 worlds. Then we can say this will append world to, oops. I think I created a new file. So let's see, git status. I accidentally added file.txt, so we can just remove file.txt. Okay, sorry about that. So if we output the contents of file 2.txt, we'll see that we added another world to it. So now if we want to update our previous commit, so this is actually what we wanted to do. Instead of committing it earlier, then we can type git commit dash dash amend, and then we can type another message, updates file 2, say like correctly. So this will actually update the previous commit and use a combination of the last commit and the current changes into one commit. So this will make more sense if we type git log. We can see that it looks pretty similar to what we had before up here, where we had update creates file 1 and file 2, updates file 2. Here we have creates file 1 and file 2, and then updates file 2 correctly, and instead of a third commit that says updates file 2 correctly. So this essentially just like updates our most recent commit, in case we made like a mistake and committed it too early or something. Cool. And then finally, let's do some more kind of like in case of user error, if we want to revert some changes. So let's echo like a bad change into file1.txt. And then let's say we accidentally added that. Again, if we do git status, it should show file1 as changes not staged for commit. This is the problem with live demos. File 2 was uploaded with world. Okay. Decommit amend. Here, let's just update that. Okay. So forget about that. It's the problem with live demos is I always run into something. But let's suppose we made a bad change to file1 .text, and we added that, and then let's do git status. So we see that like file1 has been changed. We can see file1, the difference or like the contents is bad change. If we want to do the difference of the of the stage commits, we can see that our stage changes. We can see that we've added bad change into our file1, which we don't want. So when we type git status, we can see that it says we can use git restore dash dash stage to unstage the file. So when we type git restore dash dash staged file1.txt, this should unstage the file and convert it back from staged to just modified. So when we type git status, it should be in the red as a modified change that's not staged for commit. And then now when we type git diff, since git diff tells us the difference between the modified files in the most recent version, it should show bad change. And then if we want to completely get rid of those changes from like basically reverting it from the modified state to the unmodified state, essentially taking away this one bad change that we added, you can see that the git status already kind of tells us how to do that, which is helpful. So we can just type git restore file1.txt. So this moves it from modified to unmodified and essentially deletes those changes that we've made. And now when we type git status, our working tree is clean. You can do a cat of file1.txt, and it should show that there's no longer that bad change that we added earlier. So that's the full demo. I ran through as many of the commands as I could. Let's see if, or does anyone have any questions initially?
Chris,
Yeah.
I have two questions. Once you have committed a file, can you uncommit it?
Yes, but it takes a little bit more work to do. Generally, if people make a mistake and commit a file that they didn't want to commit,
Would you just like delete it?
so you can either make a following commit to remove the file, and have that in a separate version, or you can use the amend that we talked about earlier, git commit dash dash amend, which should update the previous commit to use the like whatever new stage changes that you wanted.
So, I guess if you have a way to like amend committed files, okay, why do you want to go through this whole process of like, I don't know, like unmodify, modify stage, and then going to commit? Why don't you just directly clone a committed file and then amend that and then be done with it?
So let me see if I understand your question correctly. Essentially, like when we're going through all these processes of starting from an unmodified file to a modified file, into a staged file, into a committed file, it's kind of like a cycle where a committed file is equivalent to like an unmodified file, where we consider something that's committed as like the most, or I guess like a version of our code. Um, so when we make a let me think, how do I put it? Um, hmm. Sorry, could you maybe elaborate your question? Let me just make sure I understand it correctly.
Well, okay. My question is, if I want to make changes to a committed file, right?
Hmm.
If you could just like make changes to a committed file directly through the get amend command, okay?
Yeah,
Why would I want to bring that file back into a modified file and then stage it and then commit it? Okay. Because that seems really tedious and it's like takes a lot more steps. Why don't I just like amend it directly as a committed file and then I'm done?
gotcha, gotcha. So what amend does is it essentially like updates a previous version of your code. So if you were hoping to have like like a difference between like one version and another version, then amend will kind of, instead of creating a whole, like say we have like version 1 and version 2, and we make a change that we want to be included in version 2 and not version 3, then we would do amend, and that would incorporate that change into version 2. But if we made a change to our code from version 2 and we wanted to call it like a whole new version 3, then instead of amending it, we would create a new commit. So this is what allows us to differentiate between different versions of our code at different times. It's completely up to you whether or not you want to incorporate like a change into a previous commit or like a new commit. But generally, the ideal practice is to make multiple commits, because the more versions you have, the more granularity there is for like debugging, or if like an issue is introduced, um, it's easier for you to identify like what specific change caused that issue, um, if you have smaller commits. If I like wrote like 1,000 lines of code and put that all into one commit, but like somewhere in the 1,000 lines there was like maybe a missing semicolon, or like some syntax issue, or like something crazy that's like hard to spot, um, then it's hard to identify like where exactly that happened if it's like hidden in like such a large amount of code. But if I broke that 1,000 lines of code up into like I don't know, like 25 lines each, and like a bunch of commits, then it's easier to identify like at what point did the version like stop working, if that makes sense. So like again, the user is free to choose how many versions they're committing, or if it's like so small, like for example, if it's like a missing semicolon and I already committed that, I'm not going to create a whole new commit to add that semicolon. I'm instead going to incorporate it into the previous commit just to make like that one character change. But if it's something more substantial, then I can choose to put it into another commit.
Wow.
Uh,
Um, and then I have one other question. This is more of a practical question, okay? Because whenever I see people use like GitHub, it's usually to share code, okay?
yeah,
And so if you're actually sharing code, I really, really doubt somebody is sitting there like typing like echo and then like adding one line of code into like Vim and stuff like that.
yeah, yeah,
Okay, yeah, like Google would have to pay you overtime or something. Um, and so what do you guys normally do? Like, where do you type that huge code and then how do you upload it into GitHub, into the whatever modified staging area? Um, because here we're doing like one line at a time for sort of
hmm
instructional purposes.
yeah,
But in real life, if I have like a Python code from
right.
like VS Code and then I want to upload that into GitHub, how do I do that?
Yeah. So, yeah, again, I like you're right. I'm only using these like echo statements to just avoid having to have like multiple programs open at once. Realistically, like in a more like typical environment, we'll have like this Git terminal open as well as like a text editor or something. You're writing code to your Git repository or your working tree. And then anytime you make changes and you save those changes, you can type git status and it'll show the changes that you've made in your text editor, like VS Code, for example. Um, so it's like I guess to answer the first part of your question, which is like more of how are we really doing this in practice, that's what it looks like in general. Is like you have a text editor, you're writing code, and then Git is picking up on those changes, deciding like, oh, if you make changes, it puts it into the modified state, and then you can from that point choose to move those modified changes into staging, and then create a commit. In
How,
terms of
how would you get the text editor to talk to Git?
so in this terminal that I have open, we have it in this directory, documents slash code in place. So I can actually pull that up uh, on my computer. So if you open like Finder, you'll be able to see like this path maps to like an actual location in your local device. Um, so a text editor works in the same way where you can open the text editor and have it navigate to a specific folder and type changes to code in there. Um,
So by text editor, are you talking about something like VS Code
yeah, like VS Code.
or like our studio or like PyCharm or something?
There's tons of different text editors out there. Yeah, essentially like something that can just modify like your code files. So Vim is also a text editor. So if I open file1.txt and I wanted to write like a Python program in
Well, I
there.
mean, I don't think I would be using Vim because the problem with Vim is like if you write a code, you can't really test it in real time. Um,
Yeah,
but if you have it open in like VS Code, you could write test, you can write test. Yeah, and so I'm just gonna forget about Vim. And so
yeah, no, don't worry about Vim.
yeah, I mean, I've
um,
never used Vim.
it's definitely a lot, and it is much nicer to use like a what they call like IDE is like a basically advanced text editor that like does a lot of like formatting and other things for you.
I mean, do you have time to kind of show like how you would link a text editor to get?
So I don't actually have access to a text editor on this laptop, um, but essentially like think of it. So when you open a text editor, you should be able to open like a certain path. So you just want that path to match like document slash code in place. So
So
it's the same like if you were using Microsoft Word and you wanted to open a document from your documents folder, you would click like open from, and then you would that like whole window would open up, and you would like select which document you're opening. So for
Um,
a text editor, instead you're selecting like a folder, and it'll open the entire folder.
and then you want to select a folder that's a Git folder,
Yeah,
right? Um, and then if it opens the get folder, whatever code you're typing in the text editor automatically get fed into that get folder. Am I understanding that correctly?
Yeah, so it's like the same folder. So any changes that you make to that folder will be recognized by Git because they're both looking at the same folder, if that makes sense.
And then if I'm saving the file in the text editor, it gets saved in that get folder.
Yeah, and then
Um,
when we try to access it in Git, it knows that it's been changed.
okay, and then if I'm accessing it in get, I would have to access it through the command line. Is that right?
Yeah, using these, if you were to use these commands, there's actually like a UI version of Git that I'm not
What's the
too familiar
UI
with. I
version
think
of
that
Git?
GitHub created. Um, that could be worth looking into as well. It adopts like the same concepts that we're looking at here, but just creates like kind of like a clickable version of it, where you can like
Oh,
select things instead of
GitHub.
typing like git add and stuff.
Okay.
Chris, I have a good practice question for you. Let's say you have
Sure.
a number of files in a folder. Um,
Okay.
and some of the files are data files, not .py
Mhm.
files, okay, or text files. And some of them are not long, some of them are long, okay. What's good practice? Is it the best thing in terms of using Git, going back and forward with GitHub back, and pulling things back in to just commit everything or just commit some things, don't omit other things?
Yeah, so that's like ultimately it's a judgment call for um whether you decide like it's worth it to do that or not. I think it's like a case by case kind of thing. If the so I would say for me if the large files are typically like unchanging, then it's fine to commit them to your repository. Since Git will essentially just store uh, like the differences between previous versions. So if it's not changing, then it's not really storing much other than the file itself. Um, if it's like I don't know, if it's like a huge file that's like constantly being changed and that's not really and that you don't really need to be tracking versions of. Um, I don't know if I can think of an example off the top of my head. Then you can actually ignore that file within Git. There's something called like a Git ignore file, which will basically tell Git to like not even try to track these files when they're like added to your directory. Because oftentimes you'll have like uh, just really gnarly like metadata items or something that doesn't really display well in like a text editor um, that you don't really need in your Git repository at all.
So
Uh,
is .git ignore just another text file? And so you just, it's
mhm.
the name of a file, you put in the stuff you want to omit, and then you add it on
Yeah,
to,
exactly. So you just type in .git ignore like what files you want Git to ignore, and then like any following like Git status, for example, that you make will ignore like whatever file you wrote in there.
thanks.
Yeah, great question. Um,
So, so Chris, is it kind of fair to say, okay, normally when you use like a text editor IDE, when you save your code, it goes into a folder that normally sits on my desktop, right?
mhm.
And then if you are working with Get, you're basically changing the location where you're saving that file of code into Get.
It's the same location. Um, so when we turn a directory into a Git directory, it doesn't actually like change the location of our original directory.
Right.
Um,
But it labels
yeah,
it as a
yeah,
Get directory so that Get could somehow magically work with it,
hmm yeah,
right?
um, yeah. Was that your an answer to your question or
Yeah, so
okay?
so I guess like what's the difference of like working with Git versus working with GitHub?
Yeah, so I'll get into that. I'm hoping we can do like a GitHub demo to see like what that looks like. But again, Git is like built on top of, or GitHub is built on top of Git. So in order to use GitHub, you need to know how to use Git. Um, so that offers like a great segue into this next demo that hopefully will be pretty quick. But oh yeah, I wanted to recap like these are the commands that we're using, but I think we're running a bit low on time. So we have another demo. I think I'll just run through it, and if you want to follow along through it, maybe now or afterwards, if you run into issues, I'm just gonna go through it. But basically, we're gonna want to sign up for GitHub and then create a new repository. So I'm gonna skip the sign up step. It's pretty similar to like most sign up steps of like any website. So I already have an account. If you already have an account, feel free to just log in and follow along. But this is my GitHub page. If you hit create, this plus button at the top right, you can create a new repository. And then there are a bunch of these options. You can essentially just hit or like type in the repository name and then mark yourself as the owner. And then select a public repository, hit create repository. That should create a new completely empty repository. And then let's say we wanted to upload our existing code in place directory as like into this Git repository. So this is like basically an online repository that's hosted by GitHub. And we want to put the code that we added from earlier into this online repository. We can copy these commands. So I'm just gonna show you what that looks like. So let me switch back to my terminal. So here, this is back to where we were. I'm just gonna copy this first command, git remote add. This essentially allows us to push to the repository that we just created. This is redundant, and then we'll just say git push -u origin.main. So these were all of the commands that were on like the repository that we created. So this git push command essentially uploads our existing changes from the code in place directory to the code in place repository that we have that we just created on GitHub. Okay, I think like so full disclosure, like I'm presenting on my work laptop, so I don't have access to external internet, but in like a real scenario, this would work and this would upload to GitHub. If anyone's following along and this worked for them, just hit refresh on your GitHub page on the repository that you just created, and it should show the changes that you, or like the files that you added previously in the GitHub repository. So obviously for me, it's going to be empty, but if you go back here, you hit refresh, yeah, it should show some files. Sorry, I can't show you what that looks like.
Show some files where?
Just like on this page, it should show. I don't know if there's like a, like, let's see if we can create a file here. And let's commit these. So yeah, now like we can see I've created this file. It should show it. And it no longer shows like that initial page of uploading like that to the directory.
So basically now you have a file on your local computer in Git, well, saved in a Git folder, but you've also pushed that file into your GitHub repository,
Yes.
right? And so like in the vast universe, there's actually two copies of that file existing, one in your GitHub repository and one on your computer,
Exactly.
under Git or whatever.
Yeah. And because this is an online thing, you can also like log in from elsewhere and like pull the same code and make changes to it. So let me go back to that was like the quick demo that I had for GitHub. Let me go back to this. So this is where these two new commands come into handy. So we have git pull and git push. Pull will essentially fetch any commits from like the online repository that we have. So essentially, like if we call git pull on this code in place repository that we have, obviously right now, if you try it, you feel free to try it. There's nothing to pull because we just uploaded our most recent changes to the branch. But say someone else like made some changes to that online version of your code, and that doesn't exist on your local device yet, you can do a git pull, and that will pull like those changes into your local working tree. And then you'll have like the most updated version of the code. So this is where like the collaboration comes in, into play. On the other side, git push will upload the changes that you have in your local Git directory to the online GitHub directory. So that's what we just did earlier. Like the default command was git push from like when we created the new repository, it said we can do like git remote add, git branch, and then git push. So that git push allowed us to upload our local code into GitHub. So yeah, that's how that works. And then the one big rule of using GitHub and like these commands is that before you push, you always want to pull. This is because if you try to push your commits to the repository and you don't have the most recent changes, there's going to be like a conflict. So you want to do a git pull. This will fetch all of the most updated versions of the code to your local device. And then once you figure out how to kind of like sort those out on your local device, you'll push your changes back to the repository, the GitHub repository. So yeah, just remember to pull before you push. That's just like a big rule of thumb.
Wait, why do you want to pull before you push?
So you want to make sure that you have all of the most recent changes from the GitHub
Oh,
directory before you upload any further changes.
okay.
If that
Um,
makes sense.
and then previously you showed this command like get branch. What does
Mhm.
that do again?
So branch will allow you to create like an alternate working tree of like your code. This is particularly useful if you want to like work on multiple different changes at once. Um, so if you're working on like let me try to think like I think it's just say if you're working on like file A and you want to I'm struggling to think of a scenario right now, but we're not going to cover branch right now, but it is a very useful um, topic.
Well,
Uh,
suppose if you have a large Python code with like multiple different functions, and then if you have
yeah,
like different teams working on different functions, right? You could potentially assign each function to a branch, right?
yes. There's a lot of different ways to use branches as well. But yeah, you can assign things to different branches. A lot of like get like as you go deeper into Git, there's a lot of like merging and like complicated things that that you end up doing, and a lot of it just involves like branches, and then ultimately like whatever exists on GitHub in like the main branch is going to be like one long string of commits. And whenever you're working on like an alternate branch, um, you're going to want to figure out how you're going to merge that back onto like the main branch. So like you can make separate changes on like a separate branch, but ultimately like the work that you're doing on this branch is something that you want to like eventually merge into the main branch, because that's what's like kind of like the front facing version of the code that you want people to see. The branch is mostly for um like work. But yeah, great question. Branches are definitely something that would be useful to learn about. I just didn't think we would have time to cover it today. So we are running a bit low on time. I'll cover Jupyter Notebook really quickly, but I don't think we have time for the demo. So I'll just talk about what it was, and I imagine most of you have it downloaded at this point. So I'll link like a resource that you can use and follow along just to play around with like how to use Jupyter Notebook. And if you are already familiar with Jupyter Notebook, then you don't have to go through this tutorial. It's like pretty straightforward, just like typing some Python code into it and running it, and just like figuring out how to use it. But we will be using Jupyter Notebook in some of the other classes, so would be useful to just kind of familiarize yourself with it.
Well, do you think for your next session, like NumPy is going to take a full 2 hours?
I think it could, but if we want to set aside some time to go to like cover Jupyter Notebook or something, I'm happy to like adapt that. If that's what you were asking.
Yeah,
But
yeah.
yeah. I can try to work that in. But the demo is like not super involved. It was more of just like dipping your toes in the water, trying out how to use it. But I can spend some time at the beginning to go through it. I'll just like run through it pretty quick. But essentially what Jupyter Notebook is, it's like a web-based computing platform. So for those of you who were able to get it installed successfully and launched successfully, you can see that it launched in your browser, and it showed like a web page that essentially like reproduced all of the files and folders on your computer, or as just like a file tree, kind of like Windows Explorer or Finder. But you can actually like create like Jupyter notebooks in specific directories um, from that view. So Jupyter Notebook is like essentially somewhere that we can write documentation, write code, and run code all in like one application, which is really popular in data science because a lot of data science is just like running code and then sharing your results with other data scientists. So having to like being able to write documentation and run code in the same place is really useful. You can kind of just share your notebooks, which will like be able to like other users can replicate your findings or kind of just like see what you worked on. An alternative to Jupyter Notebook is Google Colab. It's hosted on the cloud, which is like the main difference, I believe. But this also means that it's like accessible across multiple devices as long as you log into your same Google account. And I believe there's some sort of collaboration element to it that exists, but I personally haven't used it. And as far as I know, they're about like the same in terms of like functionality. And whether you choose to use Jupyter Notebook or Google Colab is ultimately up to your personal preference. But like for, I guess, future classes, I'm planning on using Jupyter Notebook for that. So maybe easier to follow along, but again, I think they're really similar. So I don't know how much trouble you would have using Google Colab. But yeah, that's kind of it about Jupyter Notebook. Sorry, I can't do the demo right now. I wanted to leave like the last 10 minutes for Q&A, and any other like closing thoughts.
Well,
Um,
when people are asking you questions, I could just share my Jupyter notebook so that people can see what it kind of looks like. If that's okay.
yeah, I mean that would be great too, if you want
Um,
to share that.
so I think if you got Jupyter Notebook installed correctly, it should bring you to something like this.
Yeah, I'll
Okay.
stop sharing.
Um, and then I think I have to find a file that is a Jupyter Notebook. And so all of these like gray things is where supposedly you can type in code. Um, in an actual Jupyter notebook. And then usually there's like a triangle. You could like hit run and then it will like run that particular gray block. Um, but this is a document that like after you type all of your code, you could like knit it into an HTML document and then send it to someone. I never quite understood what is the point of a Jupyter notebook other than converting it into an HTML document. Um, Perhaps you can comment on that, because I don't know why I wouldn't just do this in like the terminal or something.
Yeah, I think essentially it's popular because you can put everything in one spot. Like you can run all of these things in like a Python interpreter, but it's going to be hard to, I guess, like you said, like you can convert it into HTML, which is easy to kind of share with others, to show like any results of the code that you wrote, um, or anything like that. So it's mostly so that it's like a good way to communicate like your findings and kind of like your processes for any like data science projects that you work on.
Yeah, I would also say that for any complicated project, Jupyter Notebooks is absolutely fantastic, and it really shines, when you're doing plots and stuff like that. It's like all in one place. You got it. Unfortunately, HTML doesn't copy everything. Um, but anyway, that's a different story.
Yeah, I'm not too familiar with like exporting Jupyter notebooks, but I know like it can be done. I don't know if HTML is like the preferred format, but I'm sure there are ways you can do that. But yeah, I'd like to leave like the last 5 minutes for questions, or if